Okay. All right. So we're gonna just finish off similarity. What was it? Similarity and similarity transformations. All right. So, the question for today is, what is your favorite drink? All right. So, what we're gonna be learning, what we learned in this last unit was the idea that similarity is just this idea of things decreasing in size, so all the shapes and everything should stay exactly the same. So that's basically what this is talking about. Throughout the year, artists conduct metalworking. So it's just this idea that everything keeps the same shape, it just gets smaller. So let's move on to slide 10. So now we're going to talk about similarity in triangles. I've said this like several times throughout this class, but I can't emphasize it enough. And the reason why I do it isn't because I've seen it with you guys. I think it's just because of the fact that I always thought this formula was hard. And I've seen some students have trouble with it, but the easiest way to remember it is just the Pythagorean theorem. It's this idea like, what's the distance between this point and this point over here? So if you're ever finding the distance, so let's say you have 2 points, the easiest way to figure out the distance is a straight line, and you just have to think of it this way. This is kind of like a right triangle. You have to figure out how far your x2 is from your x1, so the x value. And then you also have to figure out how far away your y values are, your y2 from your y1. So in other words, this point right here has a point x and y, and we're going to call it y1, y2. So if you subtract it, all you're doing is you're finding this point, this length right here. And if you subtract it, these, you're going to find a length right here. And then that makes your little connection thing here, which is your distance. So all of this is the distance formula. It's d squared equals a squared plus b squared. I know it's usually c, but I'm just calling it d right now. So it links up with this. And if you wanted to figure this out even more, you would just square root it. How do you figure out what a is? Well, you figure out a by taking your x2, take away your x1. So instead of writing a, I'm going to write this. So it's just again, it's literally just the Pythagorean theorem. I know I did it earlier in the last video, the part one of this. So let's figure this out. So calculate the ratio of this. So let's go into our GeoGebra. Similarity transformation. All right, and they want us to find the distance of show your work to confirm using GeoGebra tools. I feel this is really dumb. They're like, we want you to show your work, and by the way, we're also going to tell you that there's a way to do it easier. I don't like how they're doing that. I think it's kind of dumb. Use the distance formula to calculate the ratio sides of a side. So just to make it easier, I'm just going to say the sides. We're just going to do AB, and we're going to do DE. And in order to figure this out, we have to use the square root of this formula. I'll do it the long way. I know I did the short way last time, but I'll do it the long way this time. Mentum, why do you... Everywhere I've gone, guys, this little caret symbol is exponents. Edmentum is special, or Edmentum thinks it's special, and it's like, we're not going to make it shift 6. We're going to make it control up. All right, and we're going to add the y values being subtracted together. So we're going to subtract the x values, square them, subtract the y values, and then square them is basically what we're doing here. All right, so let's look at here. So we need to figure out the x value of our a. The x value of our a is 1. Let's find the y value of our a. The y value of our a is also 1. Now we're going to find the x value of our b. So the x value of our b, I'm getting the numbers from here, by the way, in case you guys are curious. Uh, if you don't see this, so let's pretend like this isn't here. The way you would find it would be going here and making sure it's clicked. So give me a second. There's a way to turn this off. Let's say this wasn't here and you just had this. What you would do is you would go into here, I believe it is. No, here. This little box right here. And then you would find. Oh, great. Now I don't know how to do it. Oh, there we go. And then you would find the algebra thing. So you want to find the algebra. That gives you all of the equations, all the points. All of this is really useful because it gives you a lot of information. All right, so we said that the x value was 2 and the y value of the b was 3. So, me being lazy, I'm just going to copy this, paste it. 1 take away 2 is -1. 1 take away 3 is -2. Copying that, pasting it back. So when we square this is just going to be 1 times 1, which is just +1. We're going to square this, which is just 4. And then we end up with the square root of 5. That's our AB. AB is the square root of 5. If we want to use the GeoGebra tool, what we would do is go to your measuring tools, go to distance or length, click this, and we find that it's 2.24. What's kind of cool is it actually tells us right here that's 2.24. The little letters in geometry, the little lowercase letters, just mean that it's the side opposite of whatever angle it is. So this is angle C. So right here, that's opposite. So that's going to be 2.24. And it's the same thing we got. And in case you guys are wondering, you're like, wait, but you said the square root of 5. Well, we're going to take the square root of 5 and we find out that it's about that 2.24 if we round it. So if we round it, you get that 2.24. And me being lazy, what I'm going to do is I'm going to copy all of that, paste it here, change this to DE. So I just do this because it just makes it so much easier to do. And then you can just edit the formula from there. You're using the same formula over and over again. All you're doing is changing these X's and Y's. So just change those X and Y's. So what I'm going to do here, I'm going to go back and I'm going to do it for DE. So I have 5 and 1 for my D. So I'm going to change this to 5 and 1. And just so you guys know, I could have put the 5 here, or I could have put the 5 here or here because they're X values. It doesn't matter as long as if I'm using the first spot for my D, I have to use the first spot for my D over here for the Y. So this right here is, let me turn this on. So this right here, think of it as X of D, X sub D. You can either put the X sub D here or the X sub D here, just as long as the other one ends up being the X sub E. All right, and so that's my D. Now I have to plug in my E. My E is 5. Ooh, a half. I'm sorry, 8.5. So I'm going to put in 8 where my X's go, and a -1/2 where the Y's go. I subtract this out, I get -3. The reason why it doesn't matter if I switch this, like let's pretend I had it as 8 and 5, I would end up getting a +3. Well, +3 squared is the same thing as -3 squared. So now I'm adding this, so I'm going to get a 1.5, positive 1.5, because this negative and negative makes a positive. Square this becomes 9. Squaring 1.5, I've said it like a few times. I memorized 15 times 15 because that Batman Beyond episode. It's 225, but since two numbers since two numbers are behind the decimal, that's why I have two numbers behind the decimal over here. All right, and let me see here. Then we're gonna add those together, so that ends up being 11.25. So that would end up being our answer. Let's take the square root of 11.25. 11 1/4. Square root it. We get about 3.35. So for finding DE, we're looking for lowercase f, the side lowercase f. So if we look at the side, lowercase f is 3.35. And that's exactly what we got, 3.35. So then confirm your calculations using GeoGebra tools. Well, we already did that, but basically they were looking for this. All right, so now what we want to do is we want to try to map this out using two methods. Well, first method that we want to use is we want to find the scale factor of this. So if we're doing the scale factor of this, we want to do new versus old. So what are we mapping? Mapping ABC to EF. So the new one would be this, and the old one is that. So our scale factor is basically square root of 11.25 divided by the square root of 5. That's going to be our scale factor. Now, because of the fact that these are roots and it's going to be really hard to put in as a scale factor, we're just going to use the numbers they gave us here. So what was it? 2.25 and what was the other one? Oh, 3.25. So 2.24 divided by, or new versus old. 3.35 divided by 2.24. 0.35 divided by 2.24. Is this kind of making sense, guys? Like how I'm doing this? Anybody lost? All right. So now what we're gonna do is first of all, we're gonna dilute this by making it bigger. So what I'm gonna do is I am going to do a dilation. And I'm gonna do it in the geometry sense. So in geometry, if we're doing dilation, we do a big D, and then we're going to do a little subscript of whatever our scale factor is. And our scale factor is 3.35 divided by 2.24. So that's our first sequence, and our next sequence is how we're going to move this over. All right, so let's see what we're going to do here. So first, let's do our transformation tools, do a dilation from point. I'm dilating this whole shape by this point, and my dilation factor is 3.35 divided by 2.24. That. So we have this shape right here. So the next thing I notice is, oh, this is totally like opposite. It looks like it's like rotated. Like I have to rotate this the completely other way. So I'm going to rotate it like 180 degrees. So the next thing for rotation, if you want to rotate, hold on, let me put, oh, they don't have the little circle symbol. Never mind. Where's the O? Oh my gosh, I really hate how Adventum has this. Okay. I'm going to combine this with another movement. In geometry, whenever we want to show that we're doing another movement, we put a little O to show we're doing another transformation. And in this case, our transformation is going to be a rotation, which is a lowercase r. Capital case R is reflection. So I want to rotate it 180 degrees. So I'm going to go here. I am going to rotate. So I'm going to click this new shape, rotate about this point, and I want to do 180 degrees. And that doesn't matter if we do it clockwise or counterclockwise. Because 180 degrees is the same way either way. And apparently that was not what we wanted to do. Let's undo that. Maybe rotating at 90 degrees. 90 degrees clockwise will help. So I'm going to try to do 90 degrees clockwise. So that shape about this point, let's go clockwise. If you're doing counterclockwise, it would be 270 counterclockwise. I'm going to try to do this. All right, that looks a lot better. So I'm going to do a rotation, subscript 180, 180 degrees. And then I need to do my last transformation. So I need to get out of this subscript, put a little space here, put a little circle, and I'm going to do a transformation, which is a capital T. Basically, the only lowercase letter is rotation because there's rotation and reflection. And then I just want to rotate this. So, or move this over. So if we look here, we're going to move like half a unit up and then also 1, 2. We're going to move it up 2.5 and we're going to move it over. If we're at 1.5, we want to move it over to 5. So let me kind of use these drawing tools. Hopefully, I don't know why GeoGebra hates my drawing tool so much, but basically this is 1.5 and we're going up to 5. So I have to move over 0.5 and then another 3 units. So I have to move to the right 3.5 units. So translation, I'm going to do a little subscript here. I'm going to move to the right 3.5 units. And I'm going to move up. What did we say we were moving up? Half, and then 1, 2, 2.5 units up. And then I'll let you guys figure out how to do your sequence 2. That's how I did this. So you know there's going to be a dilation somewhere in there. What I recommend, you know what, let's just do sequence 2. That way you guys already have an idea how to do it because the activity is a lot harder. There we go. Let me undo all of this and I'll show you guys another way of doing this. So that was with rotation. I'm going to show you guys how to do this with reflection. I think I did it for that last one, but the way you would do this is you want to reflect about a line, reflect from here. Oh, you know what? Let me undo some things. Oh, I can't redo it. All right. You always want to do the dilation. That's why I kind of regretted doing that. I was like, oh no, I wanted to keep the dilation. That 3.35 divided by 2.24. All right, cool. So here's our shape. We want to reflect this one. So we're going to do a reflection. So we go to reflect about line, click my shape. I'm going to reflect over here. But let's go this way. So if I reflect here, I still have. Sorry, I'm trying to figure out how to do this with reflection. Would that work? I think they want you to do reflection, but I don't know how to draw that line. Y equals negative x. Let's see if this works. So this is a y equals negative x line. I'm thinking you can just reflect it about this line and it should work. I'm just guessing here. When it comes to this, usually I try to do the easy way. Rotation is usually the easiest way to do it when it comes to reflection. Almost. I reflected that way. And then I would reflect again. All right, so that looks like it worked. So for this one, it's the same thing, except instead of doing a nice rotation, which is honestly what you should do, um, if you want to do another type of sequence, you can do a reflection. And the reflection is going to be about the y equals negative x line. And then you're going to combine it with another reflection about the y axis. So you can tell why I usually like doing rotations. It's just less work. How's everybody doing? You guys have been quiet. You guys alive? All right, for sure. All right. We're almost done, guys. And then I'll open up to questions. So angle A. So if we want to do angle A, unfortunately, I don't know why they don't do this, but usually when they do this, they have like an angle here, but unfortunately, they didn't do that for us. So, big tip, the angles are going to be the same. These are similar because we were able to map it out with dilation. If you can map it out without dilation, that means that they're congruent. But because we have to dilate, we know it has to be some type of similarity. So, let me do my angles. So, I'm going to undo all this. And they're asking for angle A. So again, if you guys need help with this, always think of it. If you're doing angle A, you want to look at the other two sides and you want to go counterclockwise. So the opposite side of clock. So we want to go from C to B. So in this case, I'm going to go to my measuring tools, go to angle A or C, A, B. And if I want to go angle B, I'm looking at A going to B. I want to go counterclockwise. So I'm going to go A, B, then C. And then for C, I want to go from B to A counterclockwise. If I go from A to B, I'm going clockwise, and you'll see that you get the exact wrong side. So always go counterclockwise. So we're going to go this way, which means B to A. So B, C, A. Oh my gosh. B, C. Is it not on the measuring tool? B, C, A. Oh, I think it was. It was just so tiny of an angle. So we have 26.57, 6.57. Angle B is 135. Luckily, that one was easy to type in. No decimal. And the last one is 18.43. Now we're going to do the angle measurements of this one. So I'm going to try to do this. Let's see how fast I can do this. All right, I want angle D, so I want to go counterclockwise. So I'm going to go from F to E, F, E, E. Now I'm going to want to do angle E, so I want to go counterclockwise. So from D to F, D, E, F. Now I want to do F. I want to go counterclockwise. So from E to D. So E, F, D. So I know these are usually a pain, guys, but with practice, you get used to identifying them. Um, so don't just skip these over because it gets more frustrating. Trust me, I've gotten a lot of assignments returned to students, and it just gets more and more frustrating for them if they don't practice it from the first time around. So if you look here, the angle stayed the same. So compare the corresponding angles. The angles of the corresponding vertices. Vertices are the corners, basically. So the angles of the corresponding vertices are congruent. Use the definition of similarities to explain the relationship. Since similar means the same shape, then the angles of a similar triangle must be congruent to their corresponding side. So that's a long way of saying this. The shorter way of kind of saying this is similar means the same shape. So if you move the triangle around, the angle still should stay the same. All right, so now we're gonna try to do all this. We're gonna insert our sides and we're gonna see if they work out. So here's the thing. We are going to, oops, that's not what I want to do. Wait for me to, I guess you can't really adjust this unless you type stuff in. I just don't like how this looks. All right. So what we're gonna do here is they want us to write the AB and then we're gonna multiply by something. So we're gonna write this side, we're gonna write this side, and then we're gonna multiply by the end. So our end is our scale factor. So in this case, our scale factor was 3.35 divided by 2.24 for all of them. Oh gosh. What I get for being lazy, I guess I could have typed it out in the time it took me to figure out how to paste it. All right. So that's our scale factor. We're going to figure out our sides, and we figured that out over here. So this one was square root of 5. So let's plug in the square root of 5. Square root of 5 is 2.24. Oh, you know what? I'm just going to use the GeoGebra number. The reason why they have the squiggly line is because of the fact that they're approximations. So this should be our side A, and this should be our side AB. This should be our side AC, and this should be our side BC. It's basically the side that's not included, at least for triangles. So if we're talking about little c, it's opposite of that. So if I want, so if they're talking about side AB, I want little c, which is 2.24. If I want side B, I want little a, which is 3.16. If I want CA, I want little b, which is 5. I'm going to do the same thing over here. So if I want DE, the opposite of DE is little f. So I want little f, which is 3.35. 3.35. And if I want EF, EF is going to be, EF would be little d, which is 4.744. I want DE, I want little f, which is 3. Wait, did I do this wrong? Oh, I see what I did. I thought this was DE. That was my bad. Little e. What's little e? Little e is 7.5. So I'm going to want to multiply this A by this, and I should get the new one. So basically, this multiplication should equal this. So let's check this out. So since it's a fraction, what we're going to do is we're going to multiply and then divide. So if I do 3.35 divided by 2.24, I get this fraction. I'm going to multiply that by 2.24, and I do get my 3.35. The next thing I'm going to do is I'm going to take my 3.16, 3.16 times 3.35, and I'm going to divide that by 2.24, and I get about 4.73. So 4.73. And then I'm going to take my 5. Clear this out. 5 times 5 times 3.35. Divide that by 2.24. And I end up getting about 7.78. 7.48. 7.48. 7.48. 48. And I see I'm a little off. Very little. In general, what do your observations suggest? You can calculate a corresponding side by multiplying the side by the scale factor. So what we're going to do here is basically it's asking us to figure out what we're doing here. The thing I don't like about this activity, and I know you guys hear me complain about Edmentum a lot, is it assumes you know how to convert this using a scale factor. And I'm like, well, how would you have known that unless you know to divide the sides out? So it's like, hey, figure out how to scale factor it. Oh, by the way, you need to know that you can divide the sides out to figure out the scale factor. Oh, what did you learn from this? It's like, you have to divide the sides by doing the scale factor, but I needed to know that in order to do it. So Adventum has a weird learning philosophy, so just be happy that I'm doing the exercises for you, so I can tell you what you were supposed to learn. So, how would I have done this without knowing how to do the scale factor? So then, now Adventum's going to tell you the lesson, what you were supposed to learn from all this. So this idea is that the scale factor can be calculated by new divided by old, new divided by old. You'll hear me saying that a lot, this idea of new divided by old, because that's how similarity works. So, for example, if I do 12 divided by 9, it should be the exact same thing as doing 10 divided by 7.5. So if I do 12 divided by 9, I get 1.3333. If I do 10 divided by 7.5, I should get 1.3333. If I do 8 divided by 6, I get 1.3333. So that's the idea here, is they're proportional to each other. As long as all the corresponding angles are equal, the corresponding sides are proportional. That's what they're saying right here. That's what similarity means. All right, so we have this angle. Angle A is that, angle B is that. What is the measurement of angle C? There's a similarity that exists. The measurement of angle A is this, the measurement is this. Okay, so one thing we have to learn here, they're kind of talking about two different angles, but it's not even that hard of a question. So let's say we have this and this. We have A, B, C. This is only hard if you're imagining it. Otherwise, this is actually really easy. So they're like, we know what this angle is, we know what this angle is. What's this angle? Well, we already know that these are equal, so this angle should be the same as the first angle, and then this angle is the same as this angle. So we need to figure out what this angle is. So the only way to do that is a triangle has 180 degrees. So basically 68 plus 46 plus whatever angle C is equals 180. From here, we're going to add these two. So 40 plus 60 is 100. And then 8 plus 6 is 14. So we get 114 plus angle C. I know I kind of did some Common Core math there by doing this, but I feel it's a good way for you guys to kind of start practicing how to add this really fast. I do all this in my head to make it faster. So what we're going to do here, now we have to subtract this out. So 100 take away 100, that's 0. And then 80 take away 14, so we have 70. 10 take away 80 is 70, take away 4 is 66. So we get angle C equals 66. And I did that kind of fast in my head, but I just want you guys to kind of get an idea of how to do math fast in your head. All right, so we should have an angle of 66. Perfect. All right, guys, and as always, make sure you're paying attention to your similarity principles here. Basically, the idea that this triangle is similar, so the angle should be the same. And then over the weekend, I'll record the videos for next week. And the week after, we'll just talk about questions. Let me stop the recording.